Hello, my name is Robert Smith, and I'm with New River Community College, and today we are going to back extrapolate from the name of a coordination compound to the chemical formula of the coordination compound. And it's relatively straightforward. It carries over from our last video where we took the coordination compound chemical formula and turned it to a name, used the same rules just in reverse. So again, it always lists the cation, then the anion. We know that we have sodium, but we don't know how many sodium. So leave yourself a little bit of space. And then everything else is going to be in the brackets. And we know we have tetrafluoro, which means there's 4 fluorines, and each fluorine, or 4 fluorides rather. So there's going to be 4 fluorides. So that gives an overall -4 charge. And then orate 3 is going to be gold 3. You can call it, it might show up as sodium tetrafluoro gold 3 or tetrafluoro orate 3. It's the same thing. So we have, if gold is a +3 and there's 4 -1 charges, the overall charge on the coordination compound should be -1, which means that we only have 1 sodium to counteract it because sodium is a +1. So we can just write this out directly. And that would be F4. Okay. Let's do another one. Sometimes it's easier to just, instead of, even though you're given the complementary species, in this case potassium, sometimes it's a little easier to just go ahead and write down the stuff that's inside the brackets first and then write the stuff outside the brackets. So let's start with what's in the brackets. So what's in the brackets are 6 cyanos, so 6 cyanides, and that gives a -6 charge overall because there's 6 -1 charges. And then iron 3, so we have 6 -1s and a +3, so the overall charge on this should be -3. So we have FeCN6, and this whole thing has a -3 charge inside the brackets, so we have to have a +3 charge outside the bracket to make it neutral. And potassium only has a +1, so there must be 3 potassiums. Let's do one last one. So this one is tris-ethylene diamine cobalt 3 chloride. Ethylene diamine is a more complex ligand. It's a bidentate ligand, which means it coordinates on 2 sites of the cobalt 3, the available sites. And so what we will do is write everything in the brackets, and chloride is going to be on the outside. So obviously there's a +3, or there's a plus charge somewhere on here. I guess I gave it away. So we know we have 3 ethylene diamines, and they're denoted by En. So there's 3 of them, and ethylene diamine doesn't have a charge. So you have cobalt 3+ inside, but we're not going to write that 3+. We just imply it by putting our chlorides on the outside. So there should be 3 chlorides. Now, cobalt being 3+ and ethylene diamine having no charge means that all the content inside the brackets overall has a +3 charge. That's why we have 3 chlorides, because each of them is a -1 charge, and 3 -1 -1 -1 gives us 0, which is the overall charge on the species. Now, if there had been something where we needed to write this as an ionic species, there would be an indication that there would be they would have to say that there was a charge when they ask you to write it out. So don't be so concerned about the charge unless there's a imbalance somewhere else.